In this problem, we're going to work through the problems where we're asked to use a graphing utility to interpret the results. And this can be from any outcomes that are in this course. So our first one in this section is a projectile that's fired upward. Height in feet after t seconds is given by this height function. And let's start by pulling up our calculator and putting it into our y equals. So we've got negative 16. We're going to, of course, use x in our calculator, squared. Oops, that's not squared. There it is, squared plus 800x plus 600. All right, the first part asks us to calculate h of 2 and interpret the answer in context of the problem. The easiest way to find this is to actually go to our table and see what my table's set up as. Oh look, it just showed up here. Now if it didn't start where I wanted it to, I could go to second table set and just tell it to start at 2, and then it would be the very first number that pops up here. And there it is. So at 2, 2136. I'm going to write the answers down here. So h of 2 equals 2136. And then it asks me to interpret the answer. So let's see. T is time in seconds. So after 2 seconds, we should always use units in these answers. And we're working with a projectile. So the projectile, like a rocket or something that's thrown upwards, the projectile is, and let's see, our answer is our height in feet is 2,136 feet high. All right, for part B, it asks us when the projectile will reach its maximum height. And we should notice that this is a quadratic and in parabola. And in parabolas, if we know that the max or min occurs at the vertex and that the x value is at negative b over 2a. So when x equals negative b over 2a, that's a quick way to answer that one. So let's do that. We have negative b over 2a. So that's going to be negative 800 over 2 times negative 16. The big thing to remember on the calculator when you do this is that we're going to take, negative 800. And when we divide, if we don't multiply that out, we need parentheses. So divide it by parentheses 2 times negative 16. All right? And there's our answer. It happens at 25, and in this case, seconds. All right, part C asks, well, what is that maximum height? Well, that's like figuring out what is h of 25. So that's what we're really being asked to do in part C, is we're, oh, that looks messy, doesn't it? Let's get rid of that. Okay, so in part C, we are being asked to find h of 25. So let's do what we did before. We're going to go to our table, and so it's quick. I'm just going to change that 2 to a 25, and I go to second table. And there's my answer. By the way, if I got it right, I'm going to see symmetry. So if I go up, take a look, see the same numbers. Actually, I'll drag this over so we can see it. So you'll notice that there's my maximum, and these numbers are the same, and these numbers are the same, because a parabola has symmetry. So once you find that value, you should see this in your table. But here's our answer, 10,600. So that's our maximum height, 10,600 feet. All right, now our last problem asks us for all the times when, let's get rid of this. So all the times when it is above 5,000 feet. And in order to find this, it's going to be helpful for us to find a good window, because right now, especially if my window is in a standard mode like this one, if I graph it, I'm not going to really see much of anything. There's a little bit of the parabola there. So we need a good window for this one. And just a refresher about parabolas, let's just sketch what we've got going on here. This parabola starts out somewhere, actually it starts out at 600. That's easy to pick out if I plug in 0. So it starts out at 600, it goes up, and it comes back down. Now we know it's at its maximum at 25, so we know that somewhere around 50 or slightly bit better is going to be a good x max. And then we know how high it goes. It goes all the way up to 10,600. This picture is not to scale. All right, so that's going to help us with our window. So let's pull up our window. And we can see that our x, we want to go from 0 to something a little bigger than 50. So let's go from 0 to 60, let's say. And then for our y, again, we're going to go from 0, and we're going to go up bigger than 10,600. Let's go with 12,000. Doesn't matter. It should just be bigger. And if I hit graph, there it is, the path of my projectile. So that's good, but I want to see when it's bigger than 5,000. So I'm going to go to my y2 and make that 5,000. So now I hit graph, and there's the other part. Now in order to find these 2 points, let me just grab this graph down here. So this is what we're dealing with. In order to find those 2 points, there we go, I want to, oops, pull up my calculator, find the intersection. So I'm going to hit second, trace, and I'm going to choose intersection, choice 5. And let's see, I look to be closer to the one on the right, so I'll start with that one. I just get my cursor near it. So there we go, I'm near it. I press enter 1, 2, 3 times. And there we go, 43.7 is my x, and that's my time. My y is 5,000 because that's the height I'm supposed to be. So let's see, 43.7 is this one. And now let's do that again. Second trace. I need intersection again. Now I need to go way over. Now if I go left on this one, that's kind of the longer way. If I down arrow, I end up on the horizontal line. And now I'm just going to scoot over till I'm closer to this other one. I'll let the calculator catch up with me. Oh, maybe a few more times. Okay, so now I'm ready to hit enter 1, 2, 3 times. And there's my intersection. Looks like my x is going to be 6.3 this time. So over here, 6.3, and those are the answers for part D. So when we answer part D, it says between which 2 times. We're going to say between 6.3 seconds and 43.7 seconds. All right, so now let's go on to the next problem. And here we're given a function, and we're supposed to answer some questions about it. So let's go ahead and first start with our standard window. That negative 10 to 10 is the same thing as zoom standard, so that's 6. I'm going to go to my y equals. Oops, it's still graphing that last one. Go to my y equals, clear out what was there. All right, and let's put this equation in here. So we have x to the 4th minus 1/6 x to the 6th. And we graph this. All right, and there it is. First it asks if p of x is even or odd, and we'll just bring this over here. We can see symmetry just looking at it. We can see that the left half and the right half look the same. If we're not sure, we can always go to our table, and let's make sure our table is starting not at 23. Let's go like -5, and if we look at our table, we can see that we're, and I'm just go down a bit here. There we go. That's a good table to look at. You can see that we have the same numbers here and here and here. So this would be an even function. We have the same y values across from each other. All right, does the function have an absolute maximum, minimum, or neither? We'll notice that in 2 places right here, they're the same one, but they definitely have an absolute maximum. All right, next we're asked when is it less than 0? So I'm going to need, this is the part where it's less than 0, what I'm tracing right here right now. And in order to find those times, I'm going to need to see where it crosses the x-axis. So let's go back here, and we're going to go into our y equals, and we're going to actually graph 0. So we can use intersection to find that 0. So you can't see it, but there's a line right there. So now I go second calc, and I'm going to go to intersection, and I'm going to go near the one on the right, somewhere over there, and press enter 1, 2, 3 times, and there it is, 2.45. So right here is 2.45, and since I have this even symmetry, I know this is over here at negative 2.45. So my function is less than 0 from negative infinity to negative 2.45, and again from 2.45 out to infinity. All right, the next question asks, when is it decreasing? All right, so let's pull out our highlighter. We can see it's increasing here, but it's decreasing there and there. And in order to answer this question, we need a couple more points, and that's going to be, when does it hit these maximums right there and there? So let's go here, and let's just trace this. If I go up here, it seems to do this really close to 2. And if I actually enter 2 in here, I'll see that I land right up there. And so that actually is that maximum x. It occurs at 2 and also at negative 2 here. So this is the point 2, 5.3 repeating, and this is the point negative 2, 5.3 repeating. So to answer the question, when is it decreasing? It's decreasing from negative 2 to 0, and again from 2 to infinity. All right, we've got one more like this. So in this last one, let's go back to our y equals and switch it out for a new function. And we've got square root, yes, second root. And we've got x squared plus x minus 6. And if we hit graph, here's our function. Kind of looks like our square root function, and it's not clear, is it touching the axis there or not? And so one way to check is, let's see, what happens at 2? If I press 2, oops, sorry, if I go to my graph and hit trace and press 2, oh, it does have that point 2, 0. So there we go, 2, 0 right there. And then if I go on the other side, it looks like negative 3. So let's just type in negative 3 on the trace. And there it is. All right, so this is kind of like our square root graph. And part of the reason that happens is I can actually factor this and get x plus 3, x minus 2. Those are the times when this function equals 0. Now in between there we have nothing. So if I hit trace and I go to the right of this, you'll notice there's no y value. So that means nothing exists there. All right, so let's answer the questions. It asks us, when is it continuous? Well, it's continuous until we hit negative 3 and everything after 2. So from negative infinity to negative 3, and again from 2 to infinity. And then it asks if it's even, odd, or neither. Well, if it was even, we would have the same value be 2 and negative 2. So this one is actually neither. When is the function increasing? Well, let's see. Here we're going down, but here we're going up. So it's increasing from 2 to infinity. And then lastly, it asks, when is the function greater than 0? Well, it's always greater than 0, except at negative 3, which these parentheses don't include, because at negative 3 it's 0. And then it's also greater than 0 from 2 to infinity.